Welcome to my channel Fee Concepts CHM. This is the first part of the series of digital communication techniques, where we will see digital transmission of data, benefits of digital communication, disadvantages of digital communication. Digital transmission of data. The term data refers to information to be communicated. Data is in digital form if it comes from a computer. If the information is in the form of voice, video, or some other analog signal, it can be converted to digital form before it is transmitted. Digital communication was originally limited to the transmission of data between computers. Numerous large and small networks have been formed to support communication between computers. Example, local area networks, that is LANs, which permit PCs to communicate. Now, because analog signals can be readily and inexpensively converted to digital and vice versa, data communication techniques can be used to transmit voice, video, and other analog signals in digital form. Most communication today is accomplished with digital techniques. Benefits of digital communication. Transmitting information by digital means offers several important advantages over analog methods. First point is noise immunity. When a signal is sent over a medium or channel, noise is invariably added to the signal. The signal to noise ratio decreases and the signal becomes harder to recover. Noise, which is a voltage of randomly varying amplitude and frequency, easily corrupts the analog signals. Signals of insufficient amplitude can be completely obliterated by the noise. Some improvement can be achieved with pre-emphasis circuits at the transmitter and de-emphasis circuits at the receiver and other similar techniques. If the signal is analog FM, the noise can be clipped off at the receiver so that the signal can be more readily recovered, but phase modulation of the signal by the noise will still degrade quality. Digital signals, which are usually binary, are more immune to noise than analog signals because the noise amplitude must be much higher than the signal amplitude to make a binary 1 look like a binary 0 or vice versa. If the binary amplitudes for binary 0 and binary 1 are sufficiently large, the receiving circuitry can easily distinguish between 0 and 1 levels, even with a significant amount of noise. At the receiver, circuits can be set up so that the noise is clipped off. A threshold circuit made with a line receiver circuit, an op-amp comparator or a Schmitt trigger will trigger above or below the thresholds to which it is set. If the thresholds are set carefully, only the logic levels will trigger the circuit. Hence, a clean output pulse will be generated by the circuit. This process is called signal regeneration. Digital signals, like analog signals, experience distortion and attenuation when transmitted over cable or by radio. The cable acts as a low-pass filter and thus the filters out the higher harmonics in a pulse signal, causing the signal to be rounded and distorted. When a signal is transmitted by radio, its amplitude is seriously reduced. However, digital signals can be transmitted over long distances if the signal is regenerated along the way to restore the amplitude lost in the medium and to overcome the noise added in the process. When the signal reaches its destination, it has almost exactly the same shape as the original. Consequently, with digital transmission, the error rate is minimal. Next, error detection and correction. With the digital communication, transmission errors can usually be detected and even corrected. If an error occurs because of a very high noise level, it can be detected by special circuitry. The receiver recognizes that an error is contained in the transmission and data can be retransmitted. A variety of techniques have been developed to find errors in binary transmissions. In addition, elaborate error detection schemes have been developed so that the type of error and its location can be identified. This kind of information makes it possible to correct errors before the data is used at the receiver. Next, compatibility with time division multiplexing. Digital data communication is adaptable to time division multiplexing schemes. Multiplexing is a process of transmitting two or more signals simultaneously on a single communication channel or medium. There are two types of multiplexing: frequency division multiplexing, which is an analog technique using modulation methods, and time division multiplexing, which is a digital technique. Next, digital ICs. A further benefit of digital techniques is that digital ICs are smaller and easier to make than the linear ICs. Therefore, can be more complex and provide a processing capability greater than what can be accomplished with analog ICs. Next, digital signal processing, that is BSP. It is the processing of analog signals by digital methods. This involves converting an analog signal to digital and then processing with a fast digital computer. Processing means filtering, equalization, phase shifting, mixing, and other traditionally analog methods. Processing also includes data compression techniques that enhance the speed of data transmission and reduce the digital data storage capacity required for some applications. Even modulation and demodulation can be accomplished by digital signal processing. The processing is accomplished by executing unique mathematical algorithms on the computer. The digital signal is then converted back to analog form. DSP permits significant improvements in processing over equivalent analog techniques. But best of all, it permits types of processing that were never available in analog form. Finally, processing also involves storage of data. Analog data is difficult to store, but digital data is routinely stored in computers by using a variety of well-proven digital storage methods and equipment such as RAM, ROM, flash, floppy, and hard disk drives, optical drives, and tape units. Disadvantages of digital communication. There are some disadvantages to digital communication. The most important is the bandwidth size required by a digital signal. With binary techniques, the bandwidth of a signal can be 2 or more times greater than it would be with analog methods. Also, digital communication circuits are usually more complex than analog circuits. However, although more circuitry is needed to do the same job, the circuits are usually in IC form. They are inexpensive and do not require much expertise or attention on the part of the user. Thank you for watching this video.